Hello everyone, welcome to today's webinar. My name is David Kurtz, Research and Analysis Director at GlobalData, and I'll be your host. It's our pleasure to have you with us today to discuss how to extend the engine oil drain intervals in mining haul trucks. Today's webinar is brought to you by Mobil, and today's guest speaker is Roger Young, Senior Field Technical Advisor from Mobil Lubricants North America. The webinar is browser-based, so if you disconnect, click the link you received via the email to rejoin the session. Please use the help widget if you experience any technical difficulties or require any assistance, and please use the related content box to access any additional resources. If you have any questions for Roger, please send them in via the Q&A box at the bottom of your screen. As background, as you'll no doubt be aware, the mining sector faces many operational challenges these days, from productivity and cost control to safety and minimizing its environmental impact. An optimized oil drain interval can support this with multiple benefits, including cost savings, reduced downtime, improved equipment lifespan, as well as reliability and performance, a lower environmental impact, and reduced workforce exposed hours. I'd now like to pass over to Roger Young from Mobil Lubricants to take us through his analysis of how to help extend oil drain intervals in mining haul trucks. Roger, over to you.
Thanks, David. I appreciate the introduction. This is one of my favorite subjects to talk about, so it's a pleasure to be here. To kick things off, I guess we'll kind of look at our table of contents here. So this is what we're going to be looking at, setting the scene on how we approach these sorts of projects with customers. The four-step overview of the trial itself, and then at the very end we're going to look at a real-life example, and then we'll have a question and answer time there as well. So setting the scene, we added this slide. I thought it was interesting, and we may be one of the only lubricant blenders or suppliers in the world to say that we actually operate our own mine as well. So I'm very fortunate to spend a fair bit of time at this mine. So this is it's an ExxonMobil affiliate. Imperial Oil owns and operates the Kearl Oil Sands mine in northern Alberta. And we do have a very large, extensive list of equipment, shovels and truck fleet and support equipment. And so I'm very lucky in that when we're doing a lot of these sorts of trials and product development, and we use it a bit of as a proving ground, and it kind of sets us apart maybe from some of our competitors. Mobil Lubricants, we are a global supplier, so all around the world. We have fairly extensive experience in the mining world, and we have a very high focus on this sector, as it's very important to us and to our customers. So we have lots of proven, I guess, protocols to help extend oil drain intervals in the mining sector. This one's all about engine oils, but we've also done many successful projects with transmission oils, differential oils, and even shovel maintenance projects. Right now, we currently have at least 10 ODI projects on the go, and interestingly enough, we have one going on at Kearl right now. And so in the future, we may be able to share some of that story as well. So whenever we look at one of these projects, we will always sit down and have a good, frank, wholehearted discussion. What's in it for the customer, for you. So, I guess an old saying in the mining industry is it's all about the downtime. We're always trying to prevent downtime. So the other side of that is usually when we're doing a project such as this, we look at, what is the total cost of ownership of the maintenance program and how can we improve that? So by extending oil drains or even altering PM schedules, we usually can have results of increased uptime, which basically is dollars in your pocket. Now, there's always two other buckets that some may forget about or not even think about, and that's there's a safety aspect here too. So whenever we're doing projects like this, we're actually reducing the amount of exposure that laborers or mechanics or field personnel need to touch or put their hands on the equipment. And whenever we're not touching equipment, there's a reduced chance of getting hurt. And this goes even farther into environmental impact. So whenever we're extending oil drain intervals, we're having to manufacture less oil and get rid of less waste oil. So whenever we do these sorts of projects, we don't just look at the money. It's important to everybody, but we always try to look at all three of these buckets and put something in them. So now we'll talk a little bit about the process itself. So this is optimal oil drain interval, for the acronym there. And as we mentioned before, it's kind of a 4-step process. We got to look at, the feasibility. Is it worth doing? We get into the testing. We get into what do we do with what we're learning here, in the big picture, and then we'll look at the test data and try to make some good educated maintenance practices following what we've learned from that from the project. So identifying potential benefits. First of all, we got to look at the equipment. We got to look at what is the customer doing right now. So we got to assess how you're operating. We got to look at how you're doing your PM schedules, what's happening today, and then we also, it's really great to have at least 1 year of used oil analysis. Even more is even better. And this kind of takes a little look into the past. So what has been happening before? Why were we changing oil here? What was the PM schedule like at this time? And sometimes we can pick out trends that kind of can be very useful to show, maybe we have some seasonal things going on with your historic used oil analysis that we can kind of address now moving forward. Then there's the economic review. So we really need to figure out what is the ultimate benefit. What are the dollar and cents of the potential savings of this project? I've never seen one that didn't progress because there wasn't enough savings identified. However, I suppose that could happen, and a lot of that could depend on buy-in from the customer, from upper management, maybe even from shareholders. Is it worth pursuing? Is the carrot big enough at the end? Then we kind of take it on to the third step of identifying the potential benefits. What is the ODI target, and does it make sense? Where are you now? Where do we think we can be? What is too far? And we need to think about other things that we see here, filters and maintenance activity requirements. So, can we actually change the PM schedules? If we can't, well, then maybe there isn't a huge amount of value here, although there would be some oil saved and some labor saved. So there's many things that we need to really take on into consideration, and we assist with that every step of the way. And then if we think we do have enough value to pursue this project, and to put some time and effort and human assets into the project, then we'll draft up a detailed protocol. We'll outline the potential benefits before we even start and call that our target. And if at all possible, it's really great to talk to the OEMs, or maybe their dealers if the dealers are doing most of the servicing for the OEM. And it's really good. It's not on here, but if you have a good relationship with your used oil analysis lab, they can be extremely helpful when we're doing projects like this. So again, still in the feasibility analysis portion here, we want to draft up a protocol, and we have lots of information to support this. We have a history of doing a lot of these projects, so this is fairly simple to think about. However, there's still a lot that goes into it. As simple as selecting the assets, we always want to have more than one. I guess one, call it a haul truck, would not be a good sample size of a fleet of 50. So we want to have at least 3 or 4. There's a couple of reasons for this. We want to pick ones that have kind of the most severe duty cycle. We want to make sure they're running as much as possible to get good, accurate data. And there's always the chance that some piece of equipment might go down. We might lose one halfway through the trial. And if you only had one, that would be catastrophic. So, and then I guess when we're talking about asset history, if we somehow have some way of tracking, or if the mine has been tracking the amount of fuel consumption, is a very good input. It can be very useful when we're looking at the data later on. And if we're keeping track of top-ups, that would be great. Oil consumption. Some engines burn more oil than others. Gets into the third point there. Our test units, we want them to be fairly healthy. not a whole bunch of mechanical history, huge issues. Hopefully we pick one that doesn't have to get taken out of the trial because of something totally unrelated, like frame cracking, or needs major welding or something like that. And then it does say in here that break-in and end-of-life units should be avoided. I agree with that to a certain extent. However, I do try to pick units that, one that's an engine that's fairly new, one or two that are kind of in the midlife. A lot of units will operate in there. And I do like to have one that's kind of, nearing end of life, not necessarily on the brink of shutdown, or rebuild, but something that's nearing the end, because I think that creates a better sample. In the real world, we're going to have units that are getting towards the end, and they may be burning a little more oil, and maybe their fuel injectors aren't in the very best of shape, but it's probably good data to have because it does happen. Now, when we kind of look at our targets here, just as an example, let's pretend that our target was 1,000 hours for an ODI. Well, we have to test the oil a little beyond that, because I think we all know in the real world that PMs don't always happen at exactly 500 hours or 1,000 hours or whatever the schedule is set at. So a 10 to 15% margin of safety. We got to take this oil to 1,100, probably 1,200 hours to make sure that we can safely do this in the real world without harming the equipment, and have the data to prove that. Now, the duration of the testing, this is a little bit surprising, especially on trials like this when we're getting way out in hours. We want to go through about 2 or 3 cycles, or 2 or 3 full oil changes. The first oil change might still be cross-contaminated a little bit with old product. The second one should be pure and good data, and then the third one would also be pure and should support good data. Excuse me. Now, if, like in our example later, our target is 2,000 hours, we got to remember 3 cycles. Well, that's 6,000 hours. That's pretty much a year of time that this trial is going to take. So we got to be patient, and we can't get in a hurry, and we have to just realize that these things do take time to do properly. And then for sampling, we're going to be taking more samples than normal. Usually, I guess we'll just do the normal sampling that the customer used to do for the first 2 or 3 samples. But as we get up in hours, we may increase the sample frequency. And here it says 4 to 6 samples. It could even be more than that, depending on how far we're going. And a lot of times we'll either say, towards the end, we're going to sample every 100 hours, let's say, or we're going to sample every 7 days moving forward until we get a bad sample that would, go beyond condemning limits, and that would signal the end of the trial. Into the field test protocol. So this is also very important. This is where we gather a lot of the data, and this is where we need to just make sure that it's done properly, because if we make a mistake, it can set us back immensely. So getting the key parties involved. Of course, a lot of times we work fairly directly with maintenance and reliability. Sometimes those teams are combined at certain sites or with certain customers, but it doesn't just stop there. For this to really work properly, I think we need really key buy-in from upper management would be great. We've even gone so far as to talk to the mine manager about what we're doing, the reasons why we're doing it. And if you have really good buy-in from the top down, it can make the trial go a whole lot smoother, and creates more focus, and really creates a good working relationship with everybody involved. And this can also go right down to, there may be contractors on site that are actually, maybe doing the PMs, or maybe there's contractors out delivering the lubes to the equipment. We need to be fully engaged with them too, to make sure that they're doing what needs to be done. They need to be aware of what's going on, because if they're putting, let's say the wrong oil in the wrong compartment, that's also going to skew our results and could put an end to the trial. So, it's kind of, everybody needs to be on board, and the more visibility, the better. samples need to be taken accurately and from the same spot, and they need to be high quality samples. So a lot of times we'll do some sample training before we even get into one of these projects. Bad samples will again give us bad data, and we can't have that when we're dealing with this, especially when we're getting up in hours on our oil drains. Clearly identify the test equipment, so lots of labeling has to go on here. You know, if we have 3 haul trucks that are flagged as the trial units, they need to be, you know, tagged in the cab, they need to be tagged on the oil cap. We've gone so far as to even make it very difficult for somebody to put the wrong product in there, maybe a lock on the oil fill, just to make sure that we're not cross-contaminating and you know, setting our project back. And then the third part of this, reporting any abnormal conditions, and this does happen. For you know, sometimes reasons out of our control, a machine may get shut down, or maybe it sits in idles, a trial machine for a day and a half. It's really good for us to know that, because you know, we'll see something in used oil analysis that doesn't look right, even though the hours are getting put on the meter. So information like that is very good. If there's maintenance going on, like, you know, did they have a bad injector that might cause some fuel dilution? We need to know that. We'll probably see it in used oil analysis. Did it get fixed? I guess the only other thing too is sometimes like seasonal changes, hot summers can affect, you know, our results at times. If we're seeing engine overheats, stuff like that, it's really good to have as much input data as possible so we can really make good sound decisions about what we're seeing in used oil analysis. And then we get into analyzing the data. So this is where, you know, it takes a little bit of experience here maybe to look deeply into what the data is telling you, try to figure out exactly what's going on, especially if you have anything abnormal. If everything's kind of just flowing along and looking really good, then this job isn't quite as hard. But it's very seldom that we have, you know, a trial that goes flawlessly without seeing some abnormalities of some sort, and just to try to figure out, you know, what might have caused that. Is it good data? Is it bad data? Do we log it or do we throw it away? Then sometimes we're lucky enough where we can do some visual inspections. So if we were running or testing on an asset that was maybe getting towards end of life, maybe at the end of the trial, that engine gets sent away for rebuild. Well, we would love to, you know, go to the rebuild facility and see a teardown of that engine and just, you know, take some pictures and take some measurements and check the cleanliness. There's lots of things that we can learn post-mortem on some of these assets as well. So what are we really monitoring, excuse me, with used oil analysis? And I should mention this table on the right here. This is kind of a very generic table. This is some, I guess, some recommendations for things to monitor. These numbers don't really mean anything about any certain product. We can see it's an XW40, so keep that in mind. But we really, you know, we want to watch viscosity. That's, you know, the main thing that that keeps our metal components separated from each other and prevents wear. So number one, viscosity. You know, watching wear metals is extremely important. We're always watching soot, and we're always watching fuel dilution to see if something's going on there. And then watching base number, alkalinity reserve, is very important too. We don't want to go acidic. And if we go too long, there's a good chance we will go acidic, and that's when we start to see corrosion and maybe copper show up. We're also watching for heat stress, as in oxidation. We do have, you know, recommended numbers that we'll use for the high end of oxidation, and when we need to look at, you know, probably ending the trial because we're oxidized. I added this slide because this is something that I like to do personally whenever I'm doing a large or a, you know, extensive oil drain such as this. So I'll build my own custom limits, and if you can work with your used oil analysis provider to help with this, it's extremely helpful. And so, you know, a lot of OEM limits are only for 250 hours or maybe 500 hours max. I have seen some OEMs list limits out to 1,000 hours in very extreme certain conditions, but when we're trying to really go beyond that, up to like this trial here, we built, our target was 2,000 hours, but I kind of built limits here out to 2,500 hours just in case, as that little margin of error in case they went over on PMs. And I find this very helpful in that it doesn't throw a bunch of flags and alarms that aren't necessary in your used oil analysis. It really cleans up the data. So it's something to consider before you start one of these trials is maybe building your own custom limits with our help. Now into the fourth section, excuse me, regular communication. So when you're doing a trial like this, it's very good to have, touch points every so often. Keeping the communication window open is extremely important. During the trial, looking at the used oil analysis, reviewing it, and then, post-trial, now we have all this data, we have all this knowledge. What are we going to do with it? Are we actually going to go to our target? Did we meet our target? Maybe we need to back up a little bit. If our target was 2,000, maybe actually the data looks better at 1,500 hours. Does that line up with PM schedules though? Well, to be determined. So once it takes a lot of, I guess, lot of talking and trying to figure out what is the next best step and what creates the most value for the customer at the end of the day. Now we're going to dive in here to some results from an actual trial that was executed by my colleagues from the U.S. here. So this was an iron ore open pit mine from Minnesota, or in Minnesota, sorry. They were very fortunate. They actually had two different engine manufacturers here. So they had some Cummins QSK 60s, and they had some CAT trucks as well. Some of them running C175 16s, and some of them running 35 16s. So this was a really a great opportunity to test the oil on several different makes and models of haul trucks. Kind of observations here from a high level. The target was 2,000 hours. They reached that 2,000 hour target at this particular site. And they did not make their own custom limits. They actually used the normal limits that you would use for a 500 hour oil drain interval. So that, in my mind, that's very impressive. They did not see, it says, a noticeable reduction in wear metals, especially in, when we're getting out over 1,000 hours. You would expect wear metals to actually be climbing. But in this particular trial, we didn't observe that. And then we talked about viscosity and base number being extremely important. They stayed within limits on that. They did not blow out even to 2,000 hours and beyond. And we'll look at some data here to show you these results. So here is viscosity, our number one most important thing. You can see that the CAT trucks are highlighted as yellow, and the Cummins trucks are highlighted as red. And the upper and lower limits are also the dotted lines, horizontal lines. Those are also in yellow and red. And we can see here that we had the same limits for viscosity. That shouldn't change between engine manufacturers. And we wanted to stay above 12 centistokes, and we probably didn't want to go over 17, somewhere in there, 17.2. And we can see that viscosity kind of laid in there really nice. So we don't even really see a lot of initial shear with this particular product, and it is extremely shear stable in that it just stayed flatline, solid, right out to 2,300 hours there, or 2,250 hours, somewhere in there. So that was extremely impressive. The other part of it, oxidation. So this is, usually oxidation is an indication of oil age. We can see a few early high marks or high samples with the CAT units there. Not exactly sure what might have caused that. However, the majority of all of the samples were, slowly trending up, which we would expect. Oxidation should increase as we get out. But even at 2,000 hours and beyond, we didn't get to our higher limit of 25. So call that a win. Next thing we're going to talk about is base number. So this is what, prevents us from getting acidic, causing the corrosion issues. We can see that our lower limit is a little over 2.1 for base number. And all of these samples stayed above that right out to beyond 2,000 hours. So the oil has a lot of protection against acidic buildup. It has a lot of base retention. And then, sometimes considered the most important thing when you're doing one of these types of trials is wear metals. Iron it's very typical that as you extend oil drain intervals, iron will climb. Engines naturally make iron, and it's just the nature of the beast. And there's nothing we can really do about that over time. We can see that we had an upper limit here for both of the Cat and the Cummins engines of 50. We approached that at times, but we never did go beyond that. And it seems like, it is still slightly climbing linear. However, it's almost a flat line as well, from 0 to 2,000, 2,200 hours. So very impressive. I think, some C175 Cat engines say, their upper limit is actually 70 ppm at 500 hours. So we didn't even get close to that. Very good results. Copper. So copper can show up sometimes as bearing wear, or sometimes it can be due to acidic oil. We have an upper limit for Cat machines here of 25, and I see we're way up at 60 on the Cummins engines. Happily, we stayed. Looks like below 12 or 13 ppm for copper throughout the entire trial. And then last of all, lead. So lead is almost always indicative of bearing wear. If we see lead, that's always a bad thing. And usually even like small amounts of lead is not great to see in used oil analysis. So we have an upper limit of 5 ppm here for the Cat engines and 20 for the Cummins engines. And we can see that we kind of, stayed around under 4 ppm of lead all the way through up to 2,000 hours. So again, very impressive. We're not causing any bearing wear in these engines by taking them out to these call it extreme ODIs. So in summary, I guess we talked about why do we do this? There has to be perceived value to the customer to even start going down this road. Some of the benefits or the outcomes of doing one of these trials, well, I feel it really intertwines the customer, the oil supplier, even the used oil analysis lab, the OEM, maybe the dealer, maybe contractors at site. It really gets everybody working together. That's kind of an outcome that maybe isn't always expected when you start one of these things. We're actually probably watching the equipment way more closely than we ever used to. So there's a little bit of risk avoidance because we're just more eyes on the equipment. And I guess what we learn from an ODI trial, we can pass on to the rest of the components on the machine. And then it helps to optimize, make the fleet more durable, more reliable. At the end of the day, that's more money in the customer's pocket. We can also learn a lot about oil filtration, how important it is. There's been times where we'll experiment. If they don't have centrifugal oil filtration, maybe we'll add that, and the benefit of the longer oil drain interval may outweigh the costs. So there's a lot of things that can happen in the background when you're kind of halfway through one of these trials. And then it provides, ongoing monitoring of the program. So we got to hear, can we go to here? Or, it worked really good with engines. What are we doing with transmissions? Let's look into that. What about differentials and final drives? It seems to just create a really good starting point of optimizing the entire fleet in all components. That's what we have for now. I'd like to thank everybody for listening, and we'll open it up for some questions.
Great. Yes. Thank you, Roger. That was a fantastic session with some great insights. As mentioned, we're opening up the floor to some questions now from the audience. And just a reminder, in order to ask any questions to Roger, please send them in via the Q&A box at the bottom of your screen. I can see there's a question already, and it's a two-parter, Roger. So firstly, are all heavy-duty engine oils capable of these long oil drain intervals? And then for the second part, if not, what is the difference?
Okay, so to start off with, I would just say a simple no. So a lot of oils, are designed to meet minimum specifications. Right now, here in North America, if it's got to be CK4, or you probably shouldn't be running it in any modern high horsepower diesel engine. With that said, there's a lot of call them mineral or entry level grade 1540s that are CK4, and they perform very well. However, I would never try to take one of those types of products out to 2000 hours. We're not going to get there. We're going to cause damage. So we've worked very carefully with oil formulations over the many years that we've been doing this. And we've had some really fantastic products in the past, but now, this particular product, the Mobil Vac 1 Ultra 5W40 Extended Performance, is a synthetic 5W40 engine oil. The base oil technology is designed for these ultra long drain intervals, being extremely shear stable, does not lose viscosity, and very resistant to oxidation due to its synthetic base oil technology. And then the additive technology plays a large part in here too. This product is fairly heavily additized. It needs to be to try to get out there to prevent wear, prevent acidity, resist oxidation at these very long hours. So I hope that kind of explains that one.
Great, thank you. We have another one. I see this trial was only on haul trucks. Can you have the same results with the rest of the support equipment?
So, most of these trials at most, especially large mine sites, we always pick on the haul truck fleet because it's the most assets that are usually kind of the same, and they have a very similar load profile, and they're probably the easiest one to actually do oil drain extensions on. A lot of times what we find is after we do the haul truck fleet and we figure out, or we have our target, we either meet or exceed or not quite make our target, but we'll set that as the longest ODI possible. Almost all other support equipment probably won't get as far as the haul truck fleet. A really good example is dozers. Dozers are they're extremely aggressively worked. They get a lot of times they don't get much idle time, or sometimes they idle too much. They burn a lot of fuel for the size of the engine. So on assets like that, extreme applications, we usually can't quite get to the same oil drain intervals as the haul truck fleet. So a lot of times we'll have special oil drain intervals for equipment such as that. Another one might be large graders, like 24M graders. They sometimes cannot meet the same oil drain expectations as the haul truck fleet.
Great, thank you. And then next question is, will every mine see the exact same results? And if not, why?
Yeah, so you would think that if you can prove it here, you can prove it worldwide, but that's not the case. And I've ran into this quite a few times. And I think we're still learning as we go here, especially when we're getting out to these 2,000-hour drains where we've never really been before. What I've been seeing is that depends on the duty cycle, and it really seems to be dependent on fuel burn. Now, two mines in two different parts of the world, or even not very far apart, can have extremely different load conditions. So some mines are loaded up when you're going uphill. Some mines are loaded going downhill if you're high mountain mining. Floor conditions are what I find some of the most has the most effect on maybe your oil drain interval. If you have like a hard rock mine with very solid hard floor conditions, you can do very well on extended oil drains because you're not burning as much fuel. up where I work in the oil sands region, we have very soft floor conditions. So this leads to higher engine temperatures usually, and it leads to a lot more fuel burn. So we may not be able to hit the same hours that a lot of other mines are able to achieve. And the other thing is too, sometimes even the mine planning can change. Your slope ratio coming in or out of the pit sometimes changes over time, and that can actually cause more and less fuel burn, which can affect oil drain intervals.
Great, thank you, Roger. Thank you for all your answers. That's all the questions that we've got. So it just leaves me to thank Roger for his excellent presentation and Mobil for sponsoring this session. To the attendees, you'll receive an email tomorrow telling you how you can access the on-demand version of this webinar, or you can access it through our website, which is www.arena-international.com/events. Thank you to all the attendees for joining our discussion today. Goodbye.